Well, this is the first video for the Math 60 Fall Term class, and we're going to talk about solving proportions. And as always, on all of these lecture videos, if you have any questions about what I'm going over, please let me know. Please contact me. You can call me on the phone. My phone number is on the syllabus. You can email me. My email is also on the syllabus. Okay? And we'll also be doing Zoom discussions once per week, and that'll be another opportunity for you to check in and try to clear up any misunderstandings that you might have. Okay, so we're talking about solving proportions. Let's see. This idea, this concept that we're going to use to solve proportions is actually pretty old. It actually goes back a couple thousand years. I mean, this is something that the Egyptians and the Mesopotamians used to do. And then also, you know, European mathematicians did this in the Middle Ages and Renaissance and so on, and we still do it today. It's something that's sometimes called the rule of three, and it's all about essentially equating two fractions. So, let me write this down with some letters to represent what we're going to be seeing. So let's say we've got a scenario where we've got A over B equals C over D. Now, we haven't talked about algebra because this is a pre-algebra course, and we will get into a little bit of algebra after the midterm. Okay? But to solve proportions and work with percents, it's very helpful to understand some basic ideas of algebra. You can get around it if you want to, but we will be doing algebra after the midterm, and you won't be able to get around that. So, here's the idea is that in algebra, when you have an equation, you can do the same thing to both sides and keep everything equal, okay? Keep everything in balance. So, for instance, you know, if you say something like, well, obviously 3 is equal to 3, that's pretty clear, right? And if we multiply on both sides by 5, then we get 15 equals 15. It keeps everything in balance. Everything is still equal. Okay, this is pretty straightforward. Where it gets a little bit more interesting is where you actually have fractions. Let's say we have 1/2 is equal to x over 5. Okay, so this is something like what we might see in a proportion statement. And the idea here is we can multiply on both sides by 5, just like we did here, keeping everything in balance. And if we do that here, the idea here is really that these cancel each other out, and we get x is 5 over 2. So we'll do more of this, like I said, after the midterm when we talk about algebra. Okay? But we are going to use this process to solve proportions. So the idea here is that if we want to solve, if you've got two fractions that are equivalent to each other, then if you cross multiply, those cross products will also be equal to each other. So if we know that A over B equals C over D, we can also say that A times D is equal to B times C. Okay? Now, I'm not the kind of teacher who likes to just throw up conclusions without justifying them. Okay? So if you're interested in these ideas, that's fine. If you want to skip ahead to the problems and how do I do the problems, that's fine too. Okay? But I do want to fill in the space between here and here. Okay? And it's what I was just talking about a minute ago. We can multiply on both sides by B. These cancel out. A is equal to BC over D. And then we multiply on both sides by D. And these cancel out. And here we are. AD equals BC. So that's the justification for what we're going to be doing to solve these problems. Okay? So let's take a look at some problems. I'll be doing the even numbered problems on the handout, and I'll pretty much continue to do that throughout the term. I'll do the even numbers as examples, and I'll assign the odd numbers for your assignment. Okay, it is helpful to have a calculator handy. I've got this graphing calculator. You don't really need one of these. Just a standard scientific calculator would be good. They're pretty inexpensive and easy to find. So, here's the assignment. First problem here, first even problem, number 2, says 9 over a is equal to 3 over y. Okay? Now, as is true in really all topics in mathematics, there's a couple different ways to approach the solution to this problem. Okay? One of the most straightforward ways, a method that you can always fall back on, is that cross multiplication we were just talking about, right? So we would say 9 times 1 is 9, 3 times a is 3a. Okay? And then, now, we want to get the a by itself, and so we need to divide on both sides by 3. Just the same way that if we multiply on both sides by something, everything stays in balance. We can divide on both sides by the same thing, and that'll keep everything in balance. And here's our answer. Okay? And this is called the rule of 3 in historical mathematics because you've got 4 positions here, and you know 3 of them. This is a method to find the last one. Okay? Before our contemporary algebraic notation was built up, people would just say, multiply these 2, divide by this one. If you want to approach it that way, not a problem. Okay? You can also look at this, and what mathematics textbooks and instructors sometimes call solving by inspection. You can see that the 3 is getting multiplied by 3 to equal 9, and so the 1 should be multiplied by 3 to equal the a. And there it is, 1 times 3 is 3. So there's a couple different ways to approach this problem. Whichever one makes the most sense to you is really what you should be doing to solve the problem. And again, if you get confused and have any questions, please let me know. All right, let's look at a couple more here. Let's see here. Problem 4 is also pretty straightforward. We start out with 40 over 35 is equal to 2 over a. So the first thing I'm going to do is to solve this by cross multiplication. And again, this is the standard method. You can always fall back on this. It'll always work. It's pretty straightforward. You go 40 times a is 40a. 2 times 35 is 70. And then we divide on both sides by 40. And we get a. So this is going to reduce. We're going to have 7/4, which is what? 1.75. Okay. Let's double check. Yeah. All right. What else? Right? You can take the shortcut and just say, multiply these 2, divide by this one. There's your 70 divided by 40. Here it is right here in the algebra. It'll give you the 1.75 anyway. Here it's a little bit tricky. You're dividing this by 20 to get the 2, so you'd have to do 35 divided by 20 to get that 1.75. You can do that if you want to. There's nothing wrong with it. It's not as clear as those other methods, though. All right, so there's the first 2 problems. Let's see what else we've got here. Problem 6, x over 12 equals 25 over 20. Okay, so maybe this time I'll do the quick solution first, where you just multiply these 2 and divide by 20. So 12 times 25 and then divided by 20 gives us 15. Okay? If we go through the whole process, when we do the 12 times the 25, that was 300 equals 20x, and then divide on both sides by 20, and there's our x equal to 15. Okay? Now you can see that these are not whole number multiples of each other, so it's a little bit harder to solve by inspection. And so that's why I think it's a good idea to fall back on that rule of 3, multiply these 2, divide by this one. Now, if you're not sure, I mean, so if you're not sure, you know, oh, well, which do I multiply and which one do I divide by? It's always the two across from each other that you're going to multiply, right? That goes back to that idea of cross multiplication that I talked about at the beginning. And then the other number that's left is always the one that you divide by. All right, let's look at a couple more problems here. What else do we have? All right, let's see here. Oh, let's do problem 8. Got m over 36 equals 14 over 63. And so again here, if we want to solve this the quick way, you just go 36 times 14, and then divide by 63, and that tells us m is equal to 8. Okay? So the steps to get there, if we do this by formal cross multiplication, that 36 times 14 was 504 equals 63m, and then divide on both sides by 63, and there's where the m is equal to 8. Okay. Let's see here. Well, maybe we'll take a look at one more here. Let's say problem 16. So, problem 16, we've got 18 over 4 equals x over 10. And let's see, I'll do the cross multiplication here. 18 times 10 is 180. 4 times x is 4x. And then if we divide on both sides by 4, let's see, that 180 divided by 4, that should be 45. Let me double check that. Okay, so x equals 45. All right, so that's the basic idea of solving proportions, right? This is, like I said, this is what the people used to call the rule of 3, and it goes back deep into antiquity. It's been a very useful process. All right, so now let's take a look at some of the word problems. What we're going to do is we're going to take the word problems and we're going to use them to set up a proportion like the ones we were just working on, and then we'll use that solution method to solve it. Okay? The key is to set up the proportion correctly. So let's take a look at some of these. Okay, word problems. Problem 18 says, if a wire 70 feet long weighs 84 pounds, how much will 100 feet of the same wire weigh? Okay, so we know that 70 feet of the wire weighs 84 pounds, and the question is, how much is 100 feet of that wire going to weigh? Okay. So again, in setting up this proportion, you've got a couple of choices. One of them is kind of right in front of us, so I'll do that first. One of those is to match the feet up in the same proportion or fraction here. And then we want that to be equal to the 84 pounds for the 70 feet, and then x pounds for the 100 feet, because we don't know right off the bat what that's going to turn out to be. Now notice that I matched the 84 up with the 70 feet. That's very important, okay? If this weighs this much, then they either have to both be on top. They can both be on the bottom if you'd like, right? But wherever you put that 70, you've got to match it with the 84. Okay? So there's two different ways to set this up, and really one is just the reciprocal of the other. Okay? So these will both give us the same solution. Let's go ahead and solve it and see what we get. Let's see. So you can use the rule of 3. You can do 100 times 84 divided by 70. And that tells us 120 pounds. Now notice up here it's the same rule of 3. 100 times 84 divided by 70. Okay? Now in these examples I've matched the feet up in the same proportion, and I've matched the pounds up in the same proportion. We can do this a little bit differently and still get the same answer, still get the same correct answer. Now this, setting it up this way says, well, we know that 70 feet weighs 84 pounds. And then the question is asking us, how much is the 100 feet going to weigh? And so again, notice I had to be careful to match the feet up with the feet, and then I've got the pounds matched up with the pounds. And here you can see we get the same rule of 3 solution, 100 times 84 divided by 70, and so that's still going to give us that 120 pounds. If we do this algebraically, we'll have 8400 is 70x, and we divide on both sides by 70, and there's our 120 pounds. Okay, so that's how we're going to approach these word problems. The important thing is to set up your proportion correctly, all right? And the key to doing that is to matching these things up, all right? You want to match the feet up either horizontally or vertically, okay? And you want to match the pounds up either horizontally or vertically, all right? So if you choose to do it this way, you've got the feet, both feet in the same proportion, but you've got to match the weight with the correct length. And then over here, you've got the length matched up with the weight, and you just want to make sure that you keep your lengths on the top and your weights on the bottom, or vice versa. Okay? So you've got some choices to make, and again, the key is what is comfortable for you and allows you to get the correct answer. All right, so that was problem 18. Let's see here. What else? Well, let's look at problem 20. So problem 20 is saying that 3 coats cost $156. And the question is, how many coats can be bought for $364? Okay, so there's our question, and again we want to set up a proportion. This time I'll create a proportion out of these two. So we know that 3 coats cost $156, and now here we need to fit in that 364. And this is one reason why it's good to keep the units with your numbers in this problem, so that you can be sure to match things up. So here the dollars should match up with the dollars over here, and then we'll be solving for how many coats you can buy right there. Okay? And so again, if we use that rule of 3, we can do 3 times 364, and then divide by 156. And that comes out to 7. Okay? And if we use the algebra again, that 3 times 364, 1092 equals 156x. Divide on both sides by 156. And there's our x equals 7. Now, as we did in the other problem, you could have set this up with the coats together in the same proportion. So here you would say 3 coats is to x coats. And then you want the price for those 3 coats, $156, matched up with its position in the proportion. And then we don't know, oh yeah, we do know. The x coats is going to be $364. And you can see you get the same rule of 3 calculation. 3 times 364 divided by 156. We'll still get 7 out of this. All right. Let's see here. more of these word problems. What else? Problem 22. We've got, it takes 6 hours to travel 210 miles. How long or how many hours will it take to travel 385 miles? Okay, so again, there's a bunch of different things that you can do to get a correct answer. If you've got a method that you've been using for a while that works for you and gives you correct answers that's different from what I'm doing, that's fine. I don't have any problem with that. That's actually, to me, one of the great things about mathematics is as long as what you're doing is correct, you can choose any method that you'd like. It doesn't bother me at all. Okay, so let's set up a proportion here. We'll match up the hours, let's say, in the first proportion, and then that 210 miles should match up with the 6 hours, and the 385 miles matches up with the x hours. So now we have to make a calculation here. So we're going to do 6 times 385, and then divide that by 210, and that tells us that this should take 11 hours. Okay, and let's see, again, the algebra here, 385 times 6 is 2310 equals 210x. Divide on both sides by 210, and there's our x equals 11. Now, some of the other things that you can do here, like you could divide 210 divided by 6 and calculate how many miles per hour you're traveling. That gives you 35 miles an hour, and then if you divide this by 35, that'll tell you how many hours it takes. That's just another approach to doing the problem. And like I said, as long as what you're doing is correct, that's fine by me. All right, well, let's see what else we've got here. Good, and let's see. All right, so let's do 2 more of these. Problem 24. We know that a 1/4 inch on a map is 20 miles. And then how many inches are required to represent 150 miles? Okay, and again, there's a lot of other things, ways that you can reason your way to the answer for this. But I'm just going to set up a proportion and then solve it using that rule of 3. So we'll put a 1/4 on top and x on the bottom, and then over here, 20 miles and 150 miles. So now we've got to do, let's see, 20 times the x is 20x, 150 times the 1/4, 37.5. And then we'll divide on both sides by 20. Let's see what we get here. 1.875. Okay, well, let's see. Does that make sense? It seems to make sense, right? I mean, one way that you can think about this is if 20 miles is a 1/4 inch, that says that 1 inch is going to be 80 miles, right? Take 4 of these to make 1, take 4 of these to make 80. So that means 2 inches would be 160. This is just short of 2 inches to be 150. Yeah, that seems to make sense. Okay? All right, so that's problem 24. Let's look at one more of these, and then we'll call it good for this assignment. Where are we? Right, problem 26. It's a very common process that people do in wildlife management. Game and fish warden wishes to estimate the number of trout in a lake. So she catches 94 trout and tags them and returns them to the lake. So 94 trout get tagged. A few weeks later, she catches 50 trout and discovers that 12 of them are tagged. Okay, so we've got 12 trout tagged out of the 50 total that she caught. Okay, and so the question is, what's the total for the whole lake, right? So you can see how the proportion is being set up here. We've got the total number of fish, and then we've got this smaller piece that are the tagged fish. So let's see. I'll set up a proportion using these two. So we know that we've got 12 tagged out of 50 total. And then up here we want to put the tagged fish along with the tagged fish on the top. And then we'll solve for the total down here. All right. So then if we go 50 times 94, there we go, and then divide by 12, and let's see, I think the problem says round to the nearest whole number, so that would be about 392. Okay, because this is just a way to get a rough estimate on wildlife populations. Okay, so you've got the handout, or you've got the assignment. There's an answer key on the last page there, so you've got the answers for all the odd-numbered problems. After you get done with this and make sure that you understand it, go ahead and please take that online quiz. And again, if you have any questions, please let me know.